China has always been rich in natural resources, boasting abundant mineral wealth that ranks among the world's most plentiful. Consequently, China possesses a vast reservoir of resources and energy for development, utilization, and even exportation. However, reality often diverges from this perception, as few anticipated that China could be hampered by what appears to be an ordinary steel pipe. Yet, this steel pipe is far from ordinary. It's a heavy-duty seamless variant crucially employed in pivotal sectors like thermal and nuclear power generation, submarine pressurized water reactors, and offshore drilling platforms. Despite China's ascension to the world's top steel producer in the 21st century's early years, this achievement primarily pertained to quantity rather than quality. Many specialized steel materials and large steel forgings remained beyond China's independent production capabilities, as countries like the United States, Japan, and Germany rigorously controlled these pivotal technologies. Despite China's accession to the WTO, access to advanced technology and equipment remained elusive, with China expected to serve as a manufacturing base for low-end, inexpensive goods. As the Chinese market and research and development capabilities burgeoned, the nation's demand for high-grade steel pipes became almost wholly reliant on imports, which came with staggering price tags. The cost of a single ton of high-grade steel pipes could soar to $20,000, a considerable expense. While this might not seem significant for the country's development, dependence solely on imports is unsustainable for China's efficient and rapid growth. Any restrictions imposed by supplying countries would bind China completely, an undesirable scenario. Finally, in July 2020, after 3 years of effort and an investment of 500 million renminbi, Hebei Heavy Industry announced the successful development of the world's largest 50,000-ton hot extrusion press, breaking through manufacturing bottlenecks in caliber, wall thickness, and length. So, how challenging is it to manufacture a seamless steel pipe? As the name implies, a seamless steel pipe lacks seams, unlike ordinary welded pipes. It's created by heating and softening solid steel ingots or billets, piercing them to form hollow billets, and then elongating and shaping them preliminarily in an extrusion press. It's this step that presents the greatest challenge. During this process, maintaining uniform wall thickness while gradually elongating the steel pipe is crucial. Improper operation can lead to scrapped steel pipe production. For instance, seamless steel pipes required for nuclear power plants must address corrosion caused by nuclear wastewater flow. Therefore, corrosion-inhibiting alloy elements are added to the steel, heightening the technical challenge. Any mishap could result in significant time, material, and cost wastage. Thus, having suitable machinery can significantly enhance efficiency. Heavy extrusion presses shape metal in molds by releasing powerful pressure, processing not only aluminum but also other metal materials, rendering them indispensable for producing seamless steel pipes. However, due to long-standing technological blockades from the West, China has had to import seamless steel pipes at high prices. As early as the 1960s, the United States began researching heavy black metal extrusion technology and produced several sets of extrusion presses capable of producing large seamless thick-walled steel pipes. Among them, Wyman Gordon had a 31,500-ton vertical extrusion press, and countries with mature heavy black metal extrusion technology adopted a technological monopoly policy. In contrast, when the United States had a 31,500-ton press, the most potent press in China was only 3,150 tons, far from meeting production requirements, forcing China to spend a hefty price to import seamless thick-walled steel pipes from abroad. It's reported that over 90% of these high-temperature, high-pressure large-diameter thick-walled special steel pipes rely on imports. China's annual demand for such pipes exceeds 100,000 tons, and prices from Western exporters are exorbitant, reaching hundreds of thousands of dollars per ton. This means that China spends tens of billions annually on just this one item. In addition to the energy sector, industries like defense, aerospace, and aviation also rely on these seamless thick-walled steel pipes and heavy black metal extrusion technology. In this light, continuous dependence on imports in this technological field poses significant security risks for China. In order to limit China's overall development, the United States may disregard the interests of the global economic community and adopt technological sanctions and blockades. How can China feel at ease with over 70% of its critical equipment in defense, aerospace, and other vital areas controlled by foreigners? After careful consideration, China's leading heavy industry research and development entity, China North Industries Group Corporation Limited, decided to independently tackle the challenges of heavy black metal extrusion technology. Norinco's research team attempted negotiations with the U.S. Wyman Gordon Company in 2004, and was willing to pay a high price for the relevant technology but faced direct rejection. Subsequently, although Germany's SMS company initially agreed to cooperate, it demanded a colossal investment of up to $1 billion. Norinco quickly realized that these cooperation conditions were neither realistic nor fair. Consequently, Norinco decided to rely on its own efforts for research and development. Although the R&D costs were enormous, once the technology was successfully mastered, it would completely break free from dependence on others. In 2006, Norinco took the lead and initiated the so-called 360 project, in conjunction with more than 20 national research units and universities' engineers. The goal was to independently develop and manufacture a 36,000-ton black metal vertical extrusion press. This project aimed to surpass the then-leading 31,500-ton U.S. press, aiming directly at the industry's highest end. At that time, the R&D team had almost no reference materials, and Western designs for such machines were strictly confidential. They were essentially starting from scratch. In July 2009, testing of this domestically produced large-scale black metal vertical extrusion press was conducted, yielding results that exceeded all expectations. The pressure reached 36,000 tons, not only surpassing the U.S. press but also adopting Tsinghua University's original winding technology, making the production efficiency 3 times that of similar equipment in the United States. This achievement shocked the world, especially countries like the United States, Japan, and Germany, which had long imposed technological blockades. This success not only achieved a technological breakthrough for China in this field but also shattered the long-term technological monopoly of the United States, showcasing China's innovation and R&D capabilities to the world. From then on, China's manufacturing technology of large-diameter thick-walled seamless steel pipes broke foreign technical barriers, reaching the world's leading level. The independently developed extrusion presses in China not only improved the carrying capacity and fatigue resistance of key components, but also, for the first time globally, solved the technical problems of winding construction and overall installation of 1,000-ton level super-large structures. Compared with American equipment, China's self-developed equipment is superior in comprehensive performance. With the application of this technology, China no longer needs to import seamless steel pipes at high prices from abroad. The days when the United States and Japan made hefty profits by exporting large-diameter thick-walled seamless steel pipes to China are gone. The success of China's large-diameter thick-walled seamless steel pipe manufacturing technology has not only had a profound impact on critical sectors such as energy, defense, and aerospace but also greatly enhanced the country's strategic security and independent innovation capabilities. Through independent research and development efforts, Norinco has not only saved tens of billions of dollars in annual import costs but also propelled technological progress and industrial upgrading in the domestic heavy machinery manufacturing industry. Furthermore, the success of the independently developed extrusion press in China is also a contribution to the international market. It breaks the long-standing technological monopoly controlled by a few countries, allowing more countries and regions to obtain high-quality large-diameter thick-walled seamless steel pipes at more reasonable prices, promoting the healthy development of the global steel industry. That concludes today's video. What impressions did the successful development of the 50,000-ton world's largest vertical extrusion press by China leave on you? Feel free to share your thoughts in the comments section, and we'll see you in the next video.